I'm Tommy Hamilton. I'm an instructor here at Moore Norman Technology Center. I teach networking and computer repair. In addition to the things that we teach here in computer repair and networking, we also teach some things that give back to the community. One of those is a project where we've assisted Stanford University in Alzheimer's research, and it's called folding. It's protein folding. And what the research involves is us getting these small incremental work units from Stanford University computers, our computers and our spare clock cycles, process these numbers and simulate the protein building process to find out why proteins misfold in an Alzheimer's patient. What happens is this work unit gets turned back into Stanford, and their researchers look at it to discover if there's any new medications that they can help an Alzheimer's patient with. And it also goes to work for brittle bone disease. And it's just a way for us to give back to the community with all of the things that we have here in our office. I was looking for a program or a project that my students could get involved with. And so I looked at some distributed computing projects, and there are some out there. There was like Bitcoin mining and stuff like that, but it was a little self-serving. I wanted something that was more benevolent. So when I approached my students about this, everybody was really on board with it, because there's not a lot of people these days whose lives haven't been touched by Alzheimer's. And it's near and dear to my heart. My grandmother has Alzheimer's, and I know several of the staff who has been personally touched by it. So I thought, what a worthwhile project for us to do. The goal of the project is when these researchers determine, they observe a protein that's misfolded in an Alzheimer's patient's brain. They simulate, they do all these simulations to try to get a simulated protein to look like something they've already observed, so they can understand why it folds in the way it does. Once they have a solid understanding of that, then they can begin to create medications that will help combat that. So all projects need a management type of aspect to it. I have students that I put in charge as project managers, and I ask them, make me a project analysis, give me a proposal, and then stick to that proposal. You pick your team, you draft up the design, and then you execute the plan. And it's all about part of our project-based learning that we have here. We want our students here to be able to hit the ground running when they go to industry. If there's a project that needs to be done, I want my students to already have that experience in some form before they get to their career, so that they're not blindsided by a skill that they know nothing about or know anything about. And that's one of the goals that we have here.
I'm Nathaniel Chettle. I'm in Moore Norman's Network PC Support Specialist program, and we got started on this program by Hamilton approaching our class and asking if we were going to be interested in a project to give back to the community. Myself and another student were tasked with starting the program and getting it set up, doing some essentially testing on it to see if it would run properly.
There's a total of 147 actual processing cores that are involved in the project. Students are free, of course, if they want to do this at home. I have all the information. They can run it on their personal computers at home and contribute to our project. And currently, at the last check, we were out of 220,000 teams in the world, we were at 493 from the top. So we're in the top 500 of all the producers in the world right now.
By doing this, I was able to put leadership on my resume, and also this program, or this project, has many implications into the network or IT world, where we have to set up switches, we have to set up routers, we have to set up clients. And so all of that will translate very well into our careers that we will be going into in the IT field.